I'd like to look at the graph of a fairly simple hyperbolic function. These functions involve dividing a numerator by an expression in the denominator that contains x. So see the denominator here, x plus 2, 5 minus x. When you divide with fractions, be aware you cannot divide by 0. So when graphing these functions, we are going to find a limitation. We're going to find a value for the domain that is not going to work. So look at this denominator. I cannot allow myself to take 3 and divide it by 0 because that's undefined. So we cannot divide by 0, and so what I have to do is determine what value for x would cause this denominator to be 0. And that would be the number that I cannot use for x. So x, if I put a negative 2 in there and added 2 to it, I would get 0. So I have to be careful when graphing this problem to not use a value of x of a negative 2. So I'm going to create my table over here, and I'm going to pick values that start less than a negative 2. So let's go negative 5, negative 4, negative 3. Let's put negative 2 down here, knowing even though that we won't use it. Negative 1, 0, 1, and 2. And let's put those values in for x in this equation. So I'm going to erase this now. We determined we should not use a negative 2. So let's put a negative 5 in here for x. And when we add 2 to it, we get a negative 3 in the denominator. And 3 divided by a negative 3 is a negative 1. Let's now put in for x right here a negative 4 and add 2 to it. We'll get a negative 2 when we do that. 3 divided by a negative 2 is a negative 1.5. It's easier for me to think of it like that when I go to graph. Let's put in a negative 3 now for x. And when I add 2 to that, I'll get a negative 1. And 3 divided by a negative 1 is a negative 3. So again, remember, when I put a negative 2 in for x, I get 0, and we have to say undefined. So we're not going to go there. Let's go ahead and put a negative 1 in for x, and we add to that, and we'll get a positive 1. 3 divided by 1 is a positive 3. When I put in 0 for x, 0 plus 2 is 2. 3 divided by 2 is 1.5. And we're starting to see some numbers we've seen before, except for different signs. When I put a 1 in for x, 1 plus 2 is 3. 3 divided by 3 is 1. And when I put a 2 in, 2 plus 2 in the denominator is 4, I get 3/4. I'm going to go ahead and write that as 3/4. It is 0.75. As these numbers get bigger here, if I keep going, 3 plus 2 would be a 5, 3/5, which is 0.6. The next would be 3/6, which is 0.5. Let's go ahead and graph these numbers right here. When x is a negative 1, y is 3. When x is 0, y is 1.5. When x is 1, y is 1. When x is 2, y is 3/4. When x is 3, it's 0.6, and these are really hard to show. When x is 4, it's 0.5. The next one would be 3 divided by 7, and then 3 divided by 8, and then 3 divided by 9, and 3 divided by 10, and 3 divided by 11. And I hope you see that these ordered pairs are getting close to this x-axis. They will never get there. Absolutely never get there. If I put in 100 for x and added 2 to it, I'd have 3 divided by 102. 3 divided by 102 is very small, but it's not 0. And it never will become 0. So the graph of this side of this hyperbolic function is going to hover down here above the x-axis, but never touch. Now let's go to the other side. Let's graph these numbers. When x is a negative 5, 1, 2, 3, 4, 5, y is a negative 1. When x is a negative 4, y is a negative 1.5. When x is a negative 3, y is a negative 3. I want you to know if I kept going this way with x being a -6, I'd get a -3/4 and a -3/5 and a -3/6 and a -3/7 and a -3/8 and a -3/9. So over here it is also going to try to touch the x-axis, but it's not going to successfully do so. Finally, this hyperbolic function will extend down here and keep going and going and going. And of course, arrowhead's over here. And it's going to extend up here and keep going and going and going up into the heavens, up into the infinity, but it will never cross this line, which is the value for where x is equal to a -2, because we said x could never be equal to a -2. The reason why this would keep going is surrounded in this area, we could try a value like a -2.5. And if I put a -2.5 into this equation, I'd get a I'd get a -6 for an answer. So at a -2.5, I'd come down right here to a -6. And it would just I'd keep using fractions to get that. Let's go ahead and look at what our graphing calculator will do for us on this. So we'll hit the y = key. We're going to type in 3 divided by, in parentheses, x plus 2, because the calculator needs to know all of that is in the denominator. My window of a -10, 10, -10, 10 is good. Let's hit the graph key and see what it does. So there's the exact picture that I have over here. Don't forget that you could go second, and let's start our table. Since we used some numbers like a -6, let's put in a -6. And this time let's go in increments of 0.5. And then let's go second graph key to see our table. Again, you can see some of the numbers that we had. Let's see if I can show those over here. I think I can. -5, -1, -4, -1.5, -3, -3. Watch these values right here. I'm going to arrow down. Ah, look at that. Look at that error right there. So I'm wanting to tell you that if you put a function into your graphing calculator and look at the data in the form of a table, it will often tell you what the domain is or what the domain isn't. Remember, the domain is the values for x that will work. It tells you that x is a -2 will not work. You know, look at this problem over here. A value for x of 5 would be a problem. So I'm going to go ahead and let you see this equation. 2 divided by 5 minus x. And I'm going to, let's see, a value of 5 will not work. So let's go, let's start our table at 0. I'm sorry, should have gone second table set. Start our table at 0. And then let's go second graph key. So when x is 0, we get, 0.4. When x is a half, we get 0.44, and then 0.5. And x is 3, we're up here to 1. Let's see what keeps going. Oh, look, there's that error. When x is 5, right here it says an error. But don't forget, I could be copying some of these values down. X is 3, y is 1, x is 4, y is 2, x is 4.5, y is 4, to help myself graph this function. So I'm going to keep grabbing the calculator. So I'm going to come on over here, and I'm going to create a table of values in order to help myself out. I believe I started at 0, 1, 2. I'm going to go with 3, 3.5, 4, 4.5, 5, and then I'm going to go 5.5 and 6 and 7. I don't know if I'll copy all those values down from the graphing calculator, and you can't see all those right now. Let's try this. So x is 3, y is 1. I'm going to have to memorize these. 4, it's 2, and 4.5, it's 4. And then here's my error, excuse me. And then I'm going to go ahead and grab a few more of these down below that. 5.5, it's a negative 4, a negative 2, and 7 would be a negative 1, I believe. Let's plot these points. And let's just remember that right here, where x is equal to 5, right here, I cannot, when I graph this, go across this, which is called the asymptote. That's the spot that my graph cannot cross. So when I go to plot these ordered pairs, when x is 5.5, I'm going to go to right here, and y is a negative 4, I believe. And when x is 6, y is a negative 2. And when x is 7, y is a negative 1. And I'm going to do this in my head. When x is 8, y is a negative 2/3. And when it's 9, it's a negative half. So this form of the hyperbolic curve, this side of the hyperbolic function will go right like that. This other side right here, on the other side of the error, when x is 4.5, y is 4. When x is 4, y is 2. When x is 3, y is 1. I'm going to just calculate. When x is 2, y is 2/3. When it's 1, it's 2/4. When it's 0, it's 2/5. And this is just trying to approach the y-axis. It never will. On a graphing calculator, it's hard to stay off of that x-axis. Hard to do by hand as well. You'll put arrowheads on either end, and you'll just make sure you don't cross that line where x is equal to 5. Finally, let's just describe the domain of this hyperbolic function. The domain of this hyperbolic function is all real numbers where x cannot equal the number 5. The range of this hyperbolic function is the y values. So think about this. The y values. The y values are itty-bitty numbers here. They're above the x-axis. They're not 0. And they get very big. Over here, the y values are very, very small. They go down, 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 way down here. Very, very small. And they come up here and approach the x-axis. But they never go along this horizontal asymptote, which is called y is equal to 0. Y can never equal 0 in this particular problem. It is called the horizontal asymptote. So I'm trying not to touch that line. Same is true for this problem over here, so I just want to finish up hyperbolics. The domain of this problem was all real numbers where x could not equal a negative 2, could not equal a negative 2. The range of this function, that's the y values, was all real numbers where y could not equal 0, because right here the graph would never touch. It was always 3 divided by 102. 3 divided by a million. If you put a million in here for x, or 999,998, you'd get 3 divided by a million. That's not 0. So y cannot equal 0. I'm going to stick with simple hyperbolic functions for our study. You'll practice this now in your homework. And we'll go on finally to some work with some radical functions.